Cool. Thank you. All right. So welcome, everybody. Kaylee mentioned earlier that 178 people signed up. I see 61 already, so I think it's going to be a busy day. A few notes up front. So this came about, some of you may have seen the content series that we put out at NetBox Labs over the last few months about automating all across the network lifecycle. In order to tell that high-level story, we had to leave out a bunch of details. So we wanted to do some deep dives. And the first deep dive we've decided to do is around configuration management, or creating device configurations. There's going to be a blog post that follows this, so be on the lookout for that. And we haven't quite figured out how we're going to do questions yet. Probably leave it to the end, but if something seems really pertinent, we'll pull it up halfway through. Also at the end, Rich and I don't have a hard stop, so if you want to stick around, ask some questions, feel free to do so. Some of our panelists may have a hard stop, so if they have to drop off, we'll say goodbye to them just at the end of the allotted time, and we can keep going from there. But all I'm going to do is just kick us off with some introductions. So as you can see, we have a deep bench today. Unbelievable talent on the panel from all sorts of disciplines within networking, all sorts of different types of companies. I'm going to really quickly try and get through some introductions. As we have so many people here, maybe I could ask the panelists to keep it super brief. And I'm just going to go top left. Danny, do you want to introduce yourself?
Yeah. So, yeah, my name is Danny Wade. I'm a practice lead at Blue Ally, focused on network and infrastructure automation. That's pretty much what that means is basically help develop solutions, help sales sell the solutions, and then obviously engineering deliver on the solutions. So I kind of see kind of a wide breadth of how to develop, but then also how to deliver any sort of automation, infrastructure automation solution.
Perfect. Thank you, Danny. Up next, Suresh.
Hi all. So my name is Suresh. I'm based in the UK. So I have been working as a network engineer for the last 8 years. And the last 2 to 3 years, I'm mainly working on network automation. I also have a blog called Packet Switch, where I share information around networking, cloud, and automation. Yeah, that's all.
Thanks, Suresh. Up next, Mr. Schulman.
Yeah, hi, my name is Jeremy Schulman. I go by Network Automaniac on Twitter/X. I've been doing modern network automation since 2011, and for the last 5 years, I've been working at a major sports media company, helping to transform the network infrastructure team from like what I call the caveman to spaceman journey. And we've been doing some, remarkable work there.
Excellent. Thanks, Jeremy. Up next, Steinn.
Hi, Steinn, go by Steinn Z. I also do incredibly short introductions. On to Adam.
I wasn't expecting that. Hey, so I'm Adam Gertzberger, and I'm a lead automation consultant at Nomios. We're a cybersecurity and networking solution provider, mainly focused on the European space. Yeah, my background is also networking, network engineering, and I've been doing network automation for quite a few years now. So I'm very lucky to, yeah, it's my job. I get to do it every day. So I love it. Happy to be here.
Perfect. Thanks, Adam. Rich?
Yeah, hi everybody. Thanks, Mark. My name is Rich Bibby, also based in the UK. I'm a technical advocate here at NetBox Labs. So my background is as a network engineer and got into network automation a few years ago. So now I do lots of nice things like create training content, training courses, basically general advocacy for network automation and NetBox in particular. Thanks, Mark.
Thanks, Rich. My name is Mark Coleman, co-founder, chief evangelist at NetBox Labs. I do all sorts of fun stuff like this, and I'm looking forward to speaking to you all today and getting some of your questions from the chat. Rich and I are going to share the hosting. We're going to split up the topics and go through it. And I think, Rich, you're going to kick off with just some sort of high-level framing the conversation.
Absolutely. Thanks, Mark. Yeah, so just to kick it off and set the scene, really. So probably a lot of you are familiar with this slide now that we do produce at most of our webinars, and we see it everywhere. It's basically put together as an overall sort of reference architecture, if you like, for what an ideal modern network automation stack might look like. So just to set the scene for today, where we're focusing is sort of like the bottom right corner, really. So in the automation area, and obviously the devices, or sorry, the platforms in that area are going to talk to a source of truth, in this case, NetBox, to do things like generate configurations automatically. And that's the kind of thing that we're going to talk about. So they're referencing a source of truth. It could be other sources of truth are there, like maybe people are using Git and so on. But in this case, this diagram talks about NetBox as a source of truth. And we're talking about how we use the tool like that along with the automation tools to generate configurations. And ultimately, on the top right there, the network, we're talking about deploying those configurations out to the network devices as well. So hopefully that just sort of sets the scene for where we are. If you want to move on to the next slide, Mark. So this is the first sort of conversation topic really that we'd like to throw out there to start things off. So basically we're talking about, why generate configurations in the first place. Obviously, you can connect to a device over SSH and hack away at the CLI interface to configure a device. But why don't we just do that? So what are the advantages of automating the processes around configuration of network devices? So why are we doing this in the first place? If anyone wants to take a stab at that.
Yeah, I think probably I will start. So speaking from my own experience, so usually we work in a team. So I always work for a small enterprise. So you work with few people, right? So even though you can have like a standards defined in a documentation saying, okay, if you create a VLAN, the VLAN name should be this, you have to use an underscore, you shouldn't use hyphen. So you can define any kind of standard somewhere. But as network engineers, we are always kind of firefighting, right? We just wanted to get things done real quickly. So when let's say I'm trying to do some config changes, I don't really have time to go and read the documentation or standards to see, okay, this is how I'm supposed to configure the device. But if you have like a template where you can go and generate the config, for example, let's say I'm going to configure 802.1x on a new switch. If I don't have a template, I could just go and configure the switch ports in a way I personally like, rather than how it's supposed to be. How is it supposed to be doing? So what my colleague could be doing in a different way, he could be using a different description format or something. But if you have a template, we are kind of enforcing the standards. We can tell the team, okay, if you need to apply a config to a device, don't go to the CLI, just use this specific template, pass in a variables. You can get the variables from NetBox, so you can even have a really small YAML file. So you can say, okay, this is the interface, this is a VLAN going to be on this interface, and then you click a button, it actually generates the config for you. So you can now kind of enforce all the standards. So you can even go a step further and actually push the config straight to the device rather than manually configuring it on the CLI. So I think that's one of the main benefit I see from generating the config.
Okay, yeah, fantastic. Anyone else got a take on that?
Yeah, I mean, one of the big powerful capabilities of generating configs is starting your source of truth or your definition or your intended state with a very, very small set of variables. You might want to set up an IPsec tunnel, for example, and you only need like maybe 2 or 3 pieces of inputs, but what generates from that could be 100 configuration statements, depending on the box that you're configuring. So one of the powerful aspects of generating configs is it allows you to define an abstraction layer or a higher level way of expressing your intended state, and not having to worry about the lower level configuration statements. So the way I think about it is it's kind of like a high level language to a low level language. Like, writing in a high level language is like writing in Python, and writing in a low level language is like assembler. And so every machine is different. If you're configuring an Arista switch versus, say, a Juno switch, you can represent your intended configuration at a very high level of abstraction. Like, here's my VLAN, and here's my VLAN name, and here's my VLAN ID. But what it generates, depending on the device you're generating the config for, would be a very different set of configuration statements.
Just
Steinsy,
back
you had a
since I'm going to start shaking soon. So I just like to, draw it a little bit back. In my mind, there's two camps of config generation or, NetBox users. There's Money Esquire the third that can do whatever they want because they have full control of their autonomous system. And they can, do basically two types of changes. There's the standardized change, there's the non-standardized change, and then there's the emergency troubleshooting in the middle of the night. Oh God, what's happening? And to be able to do standardized changes, you have to, of course, have services, and that's a banned word where I come from. I've banned it. We don't talk about services unless we're talking about ports. We talk about solutions because it's such an overloaded term. So you have a solution. Let's say that we're doing the IPsec example. We have an IPsec router in our data center, and we are doing the IPsec service per customer. Oh, great. That's a standard change most of the time until we get a new customer comes in and says, hey, I want to talk to the pizza box from 2008 sitting in China. And you go, oh, great, this is a non-standard change. So my templates go out the window. And handling that is a very interesting and complex topic. But, the standard change is like the first goal, just define your processes. Like that's amazing. And then you can start doing your standardized changes. And, you worry about the non-standardized horror show down the line, but this is the NetBox show. So, we're going to be very NetBoxy today, but the most exciting stuff I've seen these days is coming from the guys over at InfraHub. They're doing something I'm playing around with it at night. They have a very extensible model. So, if you it's very SQL databasey, Postgresy, there's fields and columns, you have solid data, really cool stuff, and you can use it as an authoritative source of truth if you set up your environment correctly. Awesome. Then you get into the config rendering part, which is coming back on track here. Should NetBox be doing the rendering and handling everything and just exposing configs directly to devices? That's an interesting take. Some people will want to avoid it if you're doing a multi-vendor scenario. I got to meet someone at Autocon that was in the Money Esquire the third camp, but I have Arista validated designs and I just press the button and it just works because I have 2 data centers and I own all the equipment. I don't live in that world. I live in a very hard and terrible world with a lot of MSP customers. And I think we can, frame it around the standard versus non-standard change, just to frame the conversation we're having.
Got it. Yep. Okay. Thanks for that take. Anyone else, before we move on to the next question, anyone else have an opinion on that? Adam or Dan, maybe?
Yeah, I just wanted to piggyback off Jeremy about creating abstraction. So I think the hard thing that it's tough for network engineers to kind of think about is, especially as you get certified, is remembering, all the commands and everything when you write config to a box. Well, you kind of have to remove yourself from that when you get into automation. You kind of have to look at what the intent is and what you're looking to actually put on the box. So for example, with VLANs, you're looking for VLAN ID and a name, but how the VLAN's configured on the device, whether it be Cisco, Arista, Juniper, doesn't really matter per se, because you take that kind of higher level intended kind of configuration, and then you break down the nitty gritty syntax for kind of lower level. So you kind of have to break away from having that righteous feeling of, hey, I know every command for every config. And then also just to kind of add on to why generating configs. If you're kind of new to network automation, I think this is like a really easy, like low-hanging fruit. And it's not really destructive, right? So if you want to try and start your network automation, being able to generate configs, maybe not necessarily pushing the config, but just generating and having that consistent config, as Jeremy mentioned, having 100 IPsec tunnel configurations, I think that can be a big win for you if you're beginning your journey.
It is, Danny. Yeah, I think it's a huge win. Just being able to generate configurations, massive time saver straight off the bat with and it's very low impact. Well, it's zero impact to the network. Sorry, Adam, you were just going to add something quickly to just want to get your thoughts.
No, I was just going to say that I agree with both. With what everyone said. I guess the reason why is it's for consistency, and the other one is for the engineering experience. Like I think. We generate configs to make our lives easier, I hope, because, like they said, if we're adding a VPN tunnel or whatever it is, there's all of this configuration that you have to do, and all you really want is the higher level intent, which is to add a VPN tunnel. So yeah, I guess it's to make our lives easier if we can.
Yeah, absolutely.
I think there's actually one other important aspect of why generating configs, and we're talking about templates. You know, we document essentially our best practices through templates. You know, you might be working at a shop where you've got like a wiki page or a Google Doc that has, here are my, you know, snippets of configuration that represent my best practices. But those are not necessarily parameterized. They're just examples, and somebody has to copy and paste and, you know, substitute the parameters that are unique per template. By encoding templates and then version controlling your templates, you actually have a means by which you're documenting your best practices without having to duplicate, you know, the content that's in a wiki page that probably is out of date by the time you've written it, you know, based on, you know, the changes in your own environment.
Absolutely. Fantastic. Thank you very much for that, guys. That's a great first question. Mark, do you want to move on to the next one?
I do. Okay, so we talked about why generate configs. So we heard uniformity or removing lack of uniformity, making engineers' lives easier, documenting best practices. I want to talk about how we generate configs. Steinn, you touched on this. Like, should it be happening in NetBox? Many people do it in NetBox. Many people use NetBox and do it outside of NetBox. Many people don't use NetBox at all. Dan, you mentioned that generating configs is one of the great first steps to get started on an automation journey. And I think that's why we see tons and tons of tutorials about this online. But maybe I could ask the panel to talk about what they think about when they're putting together the tooling for doing something like this.
I think the first step in that tooling decision is what is the interface to the device itself? Some devices offer an API like OpenConfig or, you know, RESTconf or, you know, Yang based, you know, infrastructure management, and other devices don't, or they offer both. And so you make a choice, you know, what type of config are you going to be generating, and how you generate that are two separate questions. You know, the first one you want to ask yourself is, well, do I want to go down an open config approach if it's available to me? And what are the trade-offs of doing that? I think that's kind of an important first decision.
So yeah,
Thanks,
just to
Jeremy.
pick off that, I mean, you know, before even, you know, we get into the generation, you know, we have certain inalienable objects that we, like for the VLAN example, like we have the VLAN ID, we have a description, we have a domain where the VLAN is being placed, you know, where it's non-overlapping, and that's kind of where the value of NetBox comes in as your expression of the state that should be, you know, the source of truth. This is okay. Whatever's happening in the network that doesn't match this is a no-no, and that comes later in the process. But when we get to generating the configs, I mean, the ideal thing would be to sit on our little, you know, ivory towers and just go, yes, we will have a VLAN and it shall be placed in VLAN group X, and the customer is this, and it's connected, and we're good, we're done, and we go home. You know, Yang, RESTconf, NetMiko, Ansible CLI scraping, Terraform. I don't want to care about the low-level implementation at the end of the day. I mean, I'll tell you the truth. The only thing I have really running in prod that's 100% automated is Juniper Mist. And I'm just talking to an API and copying some templates. I mean, like, I am cheating. It's wonderful. It's wonderful. Everything else is handled by a controller like Apstra or whatever. So, you know, I'm a fraud, but it is a wonderful way to live where we've abstracted away, hey, this VLAN is assigned to this customer. It's this type of VLAN group. That means that when we run an automated process in our backend, hey, it makes it happen. You know, I don't care how it happens, whatever CLI language or whatever's being happening. That's the dream state, right?
Yeah, I mean, this is an interesting question because it's not just about tools, right? Well, what Jeremy was saying is, you know, the language, understanding the format, the interface, you know, the vendor. Not every vendor supports every interface, and every vendor has their own language as well, and you have to learn all their models. I think it kind of comes back to like, what is the template and what it is that you're trying to configure. So are you doing the base configs for the devices? Maybe that might work if you're just doing some Jinja and just, you know, doing the initial TFTP zero touch for the device. But if you're doing like high frequency changes, maybe it's a firewall and you're updating address objects, maybe you want to use the REST API for that, just because it's faster. You don't have to be doing like long commits with netconf. So I don't know. I think it depends is my answer.
So the CCTE answer, yeah, this typical Cisco certified answer is it depends, and then we just back away slowly, and we don't talk about it again. But Chelsea in the comments mentioned that do configs apply to all devices like servers, only network hardware? What's the my question to Chelsea is what's the difference between a server and a network device? Honestly, at the end of the day, it's an interface. It has an IP address. You're going to be dealing with a bash shell, or you're going to be dealing with some kind of API, but ideally in my world, we want to go above the CLI, above the vendor implementation practices, and get to like, a consensus middle of what we want to deploy as our sensible defaults, because I hate the word best practices. So we define our sensible defaults, and we're able to push that to vendor XYZ. And we're, be it a switch or a server or a IPsec tunnel that's whatever we want to do, we want to create value for our business at the end of the day. So like how we generate configs, if you have the luxury of coming from a single vendor environment, I envy you. You're doing great. I hope you enjoy your Cisco ACI setup, whoever you are, good for you. The rest of the people that are dealing with the Yang models and oh God, like we could spend an hour bashing Yang and SNMP that was Yang 0.1, as I like to call it. Like we were going to do configs in SNMP. Do you remember those days? Like that was crazy talk looking back on it. So yeah, it's a hard one.
So it sounds like the feedback we're getting here is, how you generate your configs is a whole bunch of different options. But really, you got to start with the end in mind. Like, what is it that I actually want to be changing at the other end? And I think the next question is going to touch on that a little bit as well. But maybe we can start to break out some of the concepts of what we mean exactly when we say a config. Rich, do you want to take this one?
Yeah, thanks, Mark. So one thing that crops up quite a bit is the sort of splitting up of device configurations for easier management. So, for example, you might have a base configuration that you then extend with with configuration stanzas for other areas such as AAA, syslogging, that kind of thing. So you build from a base and extend it. Or you can also sort of have partial configs where you bootstrap devices when they first come online, and perhaps even get into zero-touch provisioning, that kind of thing. So, the question is like, is there one config to rule them all, or is it good practice to sort of break things down into smaller, perhaps more manageable chunks, if you like, to structure your device configurations in that way? So yeah, anyone have any thoughts on that one?
Well, is the premise here that we're generating a text-based config, for example, like you would see for like an Arista or a Junos or whatever, using that methodology, not like an open config or a REST conf methodology? Because I think, the one config versus breaking them up, generally speaking, it's always nice to break things up into components so you can, decompose your configuration into sections like you described. Here's my NTP config. Here's my AAA config. You might have configlets per interface type. We have this construct in our system where we call them interface profiles. And those interface profiles wrap up, everything, all the services that are required for that interface. And there's a template per interface profile. So we get really, really super granular. And that allows people to control the blast radius, if you will, of making a change to a template. So this way, if somebody says, well, I need to make a change to my config templates, and we're making kind of a structural change to our AAA, we know that we're only making a change to that one file, and we don't have to worry about touching, 20 other files that also need to have that AAA config. It's just an include statement if you're using Jinja, for example.
Yeah, exactly. I get the sort of safety or minimized blast radius angle of that one very much. So yeah, if you're going to make changes to that, that's all you're going to affect. Yeah, exactly. Anyone else have a view on this one?
So when we say one config, are we saying like generating full device configurations, is it? Or
well,
we say one Jinja file that has lots of different
Well, I guess it's open to interpretation. Yeah. I mean, some people might just generate a complete device configuration, and they may deploy that and overwrite the existing configuration on a device if they make a change to one element. Some people may do that. Some people, that's far too risky to do, and they may have legacy network environments where it's just not possible. But
that's a good topic to talk about, though. Like the whole, do we want to build a full configuration and replace it every time, or do we want to just create, incremental configurations? But if we do the incremental, then obviously we have to account for removing configurations and sort of, looking at the intended state and the actual state, and then figuring out what do I need to add, remove in an imperative way. I mean, the way that we do it with our customers is we have 3 layers for the configuration. So we have a base system layer where you've got your NTP, SNMP, all that kind of config. Then you've got a network layer, which is where we do all of our NNI connectivity. So all of our, core links, backhauls, and everything. And then above that, we've got our service layer. So that's all the high frequency changes, like, whether in service provider that's configuring, VRFs and interfaces, or in enterprises that might be configuring firewall policies or VLANs. But this way we kind of isolate each of these different levels or layers based on how frequently they change. And then we can use different methodologies for generating and applying them. But we couldn't do the full replace on all of this, right? Because they're done each layer is done differently through a different orchestrator.
Right. And so is there a limitation there in the tooling or actually the end device types that prevent you from applying a configuration all in one go as well? Is that
could have a limitation, correct?
Yeah.
So, I mean, just to piggyback on that. So to go back to that, we're sitting in our data center, we're all working there with our one big router. And let's say that we have 100 customers and we're selling an IPsec service, and we're not going to think about anything else, right? So we have let's just do the line by line example where we have an AOS config or whatever, Cisco IOS if we're old school, baby. So you have things in that config that are, the IPsec profile that might be, or the basic profile that might be shared between multiple tenants, right? So that might be a a system level piece of configuration versus the actual tunnel interface, which actually belongs directly to the tenant. And we can actually model this, and we've been playing around with some of these models in NetBox especially, to derive and link the actual tunnel configuration to the NetBox object. And then you get into a really interesting, conundrum, which is validating and reapplying and different. Basically, it's a control loop. You look at what should be, you look at what is, you apply the diff. You can use Ansible for that. Ansible really lends itself to a lot of that. You can use Terraform, which is wonderful and very declarative and hardcore. And if let's say we're using iOS Cisco, we could just look at. Then we get out of the NetBox realm, and we would have to go into something that we've been playing around with, which is just imagine we have a big folder. We do a folder-based thing. Big folder. Under that are all the customers. Under that is a small snippet of Terraform code that says this is the tunnel interface IP configuration, and that whole thing gets applied to that router. And that way you're able to split up your tenancy, but we also trust NetBox to handle the IPAM part. So when we're creating that little snippet in our little folder directory to configure that little IPsec interface, we look to NetBox to go, hey, I'm about to register this public IP address to this tenant to do the IPsec tunnel. And then we create the actual Terraform configuration and apply it. And there's a million little control loops that we can use to apply this configuration, how we apply the config, which toolings we use. This is like a 6-hour talk. I hope you're not going anywhere again, because we have a long one.
Exactly. Well, I mean, before we do move on to the next topic, which actually leads into that, what you've been talking about there, Steinn, quite well. Anybody else have an opinion to offer up on this particular question?
I was actually going to say what Adam said. So depending on the device type that you are working with. So us, for example, when we are working with the campus switches, we usually have like 3 layers. So on the base layer, we always put the AAA config, because that's something you just configure it once and then kind of forget about it. You don't really make changes to AAA every time.
It's also not worth spending too much time automating those changes because they're so infrequent.
Mm-hmm.
Correct. Yeah, they are like almost static unless you want to change your TACAC server IP or something, which doesn't really happen too often. And then on the second layer, we manage all the interface config. And then the third layer is kind of everything else. But if you're working with the router, it could be slightly different. For example, if you are pairing with multiple customers over BGP, then you want to kind of put all the BGP config into one layer, because that's where you're going to be making more changes. And then you can also have a different layer for the interface IP, or you could combine the BGP with interface. So it mostly depending on the device type you're working with. But yeah, it's always best to split them up into different templates rather than having everything in one place. So yeah.
Perfect. Thank you, Suresh. Mark, that does lead quite nicely, doesn't it, into the next topic, actually, if you want to.
It's almost as if we designed it this way. So
Incredible.
how do we deploy configs? We've touched on this a couple of times already. Naturally, I think Jeremy said earlier, you got to start with the end in sight. There will be people on the call today that are just getting into their journey around this. One of the questions that came up was, so are we creating a full flat file config? Are we using something like RESTconf or something that's got an API like that? Maybe somebody could just give the lay of the land for high level options that people have when deploying configs to devices here.
You want me to jump this? I'll jump this then. So we got so I'm not going to scare you. This is going to be terrifying. If you don't know any of these words, don't worry, you can Google them later. Okay, so we have the flat file config generation. And in this example, we're working for an enterprise, not an MSP. We're single tenant. We're managing a switch, and you need to add VLANs to that switch. Okay, and you have 3 departments, VLAN 10, 20, 30, basic stuff. You can assign stuff inside a NetBox, and then you can use the information inside a NetBox to derive the information, because you've already put VLAN 10 on the interface inside of NetBox. You want to make that change happen. In reality, it happens to be Cisco IOX. So you've created either a Python script that just reads the state of NetBox and checks on this switch, which VLANs are set to which access VLANs are configured, right? And you have yourself a little standardized little config template that you can just either copy paste yourself, or you can push it automatically with certain tooling. Like we could also, instead of creating the raw text file that by the way, how did you create the raw text file, Steiny? Well, Jinja is pretty much king of the playground these days. So what you want to Google is Python and Jinja 2, and then you can just get into the, shout out to my dear departed friend, Nick Russo, who has just the best plural site content for getting started with Jinja 2. So, Nick's material is really, really good for if you're getting started with this. So if you want to create that raw file, there you go. You're able to take data inside a NetBox, render it using Python and Jinja 2. That creates a big old Cisco config file or whatever it is you need to do, and then pushes it directly to the device. Wonderful. Other options include, though, you could use Ansible, which is a wonderful, it's idempotent. It can also be procedural. It can do, you can do a lot with Ansible. You can almost do too much with Ansible. That's kind of the problem. And people start using Ansible like they use Python. So, keep that in the back of your head. If I'm using Ansible like a Python script, I might be doing something weird and wrong. I'm not saying you're doing anything wrong, but you might be. But that's the tooling approach. So you have Terraform, you have Ansible that can interact directly with your equipment. That's another option. So instead of rendering out a config like we did before, we would have a method of using a playbook, for example. Inside, let's just use the Ansible one. We would render out a playbook that says, hey, for each VLAN interface on the switch in NetBox, go and apply the appropriate VLAN, and then you have something, Ansible module. In Terraform, they're called providers. In Ansible, you have modules from Cisco for that particular switch, and you would apply that config, and then it would just loop through it. Or you can, use Ansible to create that configuration file and then dump it. You have endless options, and that's the problem. Then we get into the third category, which is not the Terraform or the Ansible or the insert, chef puppet tooling of choice. That is the open standard stuff. So the OpenConf, the Yang, all that good stuff. And then the fourth, which, this call would take forever if we went down that path, but Yang was very promising. We're not going to bash on it all day, but the ISPs pushed that stuff forward. It was a great idea on paper. I've never gotten to work in any way, shape, or form because the vendors always implement their own spec and it all turns to rubble. The fourth option, direct API access. If you can do direct API access, oh boy, you're going to have a fun time. So that means you can use stuff like if you have a Meraki switch, if you have a cloud controller, you can talk directly to their orchestrator and just tell them, hey, NetBox has these VLANs configured. I'm going to push that to the orchestrator using their either Python or some sort of library, and you can make magic happen, and you don't have to worry about pushing the config or anything like that yourself. The REST API just takes care of it. It'll error out. If you put in the value 9999 for the VLAN ID, it'll error it for you. Lots of wonderful stuff. So those are kind of the top 4 or 5. Am I missing some stuff, guys?
I think there's a really simple one that, you know, maybe was too obvious to gloss over, but one way is if you're doing a text-based configuration, you can, you know, use Jinja, say, to generate it, but to deploy it, you could do something as simple as copying that file over to the device and then using a series of CLI command, you know, automated CLI commands to load that file from, or load that config from file. And then depending on whether or not your vendor of choice offers config sessions or you know, candidate configs is the Junos term, you know, you can deploy an entire file over and over and over again, you know, the complete config, going back to the prior question, and only the changes that are necessary are applied. This is a very simple approach. It's just generate the config, you know, on your server, you know, FTP it over to the device, load it with a simple command. Very straightforward. Very easy way to get started.
Yeah, I think I will just follow up with.
Yeah, go ahead, Suresh.
Sorry, I will just follow up with Jeremy. So if I ever needed to generate the text-based CLI commands, so our tools of choice is Jinja 2 for template. And then if you don't have NetBox, we put all the actual placeholder values into a YAML file and then use Python to mix both together and then generate the actual config. And then if I had to push the config to the actual devices, we always use Napalm, because with Napalm, you can actually see what's going to be changed. For example, if you have Arista devices, you can actually do a dry run. So you can generate the config and then tell Napalm to push that config to Arista. Then it will actually shows you what's going to be changed on the actual live device before you actually apply the config. So I think Napalm is quite useful for the actual CLI commands.
Yeah, to your point, I think Napalm under the hood does the file transfer technique and uses the CLI commands.
Yes.
So, you know, using a pre-built library like Napalm or Nornir, or, you know, pick your favorite, is really a great way to get started. But there's a learning curve, right? So, you know, anytime somebody's getting started, they kind of feel overwhelmed by there are too many choices. You know, how do I even get started? So trying to provide simple cases like I think Napalm is a really good choice to get started, because it allows somebody to go from aha to cha-ching. I need to do this thing and I need to do it really simply by just following some of the best examples that they have in their documentation.
Yeah,
Maybe
definitely,
just
because
one
I
thing
felt
to
the
layer
same.
on quickly. Sorry, just a quick question before we wrap this one up. You know, that's a ton of options. And I think one of the hardest things about learning a new space is understanding why there's so many ways to do the same thing. I think because generating flat files and pushing them is like the default approach. Maybe you were about to say this, Suresh, but like, why did we move on from that? Why are there other options?
I guess because the configuration starts to get very large. And especially if you're going for that approach I was saying, where you're splitting it up, Jinja doesn't always work, or Jinja isn't always the best choice for generating those kind of configurations. So I actually haven't written Jinja in a very long time, because I've been doing so much XML and Yang that
I'm so
it's
sorry.
a different way of doing it. I'm not saying that Jinja or Yang is better or worse, but I do quite like the whole netconf approach, that you can replace specific elements is very nice. And I think when you start getting into that world of kind of like assigning ownership and saying that, you know, this element, so I don't know, say BGP neighbors on this device, they are managed by this process, but all the interfaces are managed by something else. And it allows you to replace at very specific levels. Whereas this, initial approach with the ginger and the replacing, it's kind of like all or nothing. But it's definitely, I'm not saying it's the wrong way or the right way. I think it just depends. When you get a massive configuration, you need to start thinking about co-managing and how you have people doing manual changes, but also have orchestrators, have multiple orchestrators managing the same devices.
Thanks, Adam. Suresh, I think I cut you off. Yeah, let Suresh get his point in. Yeah.
I can't remember what I was going to say. I think I was just responding to Jeremy's point around, you don't want to overwhelm people with new tools. I just said I felt the same when I started using Napalm. I don't know, when I started using Napalm, it was too complicated to me. So I just started generating the config and then applying directly onto the device. Then I kind of gradually moved into using Napalm to push the config. So yeah, that's what I was going to say.
All right, thanks, Suresh. Steinn, hold that thought. We're going to go to the next and last question that's going to be led by Rich.
Yes. So are all devices born equal? So what we mean by this is you may have networks with older devices that aren't necessarily as automatable, perhaps as where you're getting into netconf or restconf and things like that, which is all lovely, and you're just replacing standards of configuration. So you may have older devices in the network. So how do we approach that? But also even to the level of some vendors, for example, would have different versions of their network operating system across different product lines. We all know one big vendor in particular that's famous for that. So, how are we tackling that? Is there kind of like a general approach to say older legacy devices and differing device types? Does it become just an abstraction piece with just use something like Napalm and that takes care of it, or any other approaches that people consider?
Well, to answer the question on the screen, not all devices are born equal. I think we would all agree to that based on, the premise that you just put out there. If a device offers a candidate config capability, that's a huge uplift. And you'll see that in, modern network operating systems, whereas in legacy operating systems, you wouldn't. Sometimes you have to ask yourself, is it even worth automating, certain devices that are so old, or what is the practice for deploying them? So for example, we might generate the configs for an older device, but apply them manually just to make sure that it goes correctly, just because these devices are so old and they're so fragile in the way that they're meant to be or not meant to be automated. So sometimes we have to take a different practice based on, the devices and their legacy.
But yeah, that makes a lot of sense. I'd also like to throw in actually firewalls in this discussion as well. So, in terms of device type, so firewalls can have just huge access control lists as well. Has anyone got any thoughts on sort of ways to manage firewall, automate firewall configurations as well in this?
I mean, if you're using Junos firewalls, then you can use, like Jeremy said, the candidate configuration. You can use all the same stuff on that. If you're using like Fortinet or Palo Alto, they do have very good REST APIs, but then you don't have a candidate session for that. You're gonna have to, pull the address objects, pull the services, pull the firewall policies, and compare. Look at your intended versus expected, and figure out what you need to do to meet that. So yeah, so that's the other approach. But if you're lucky enough to have the SRX firewalls, then you can just do the same thing you've done for your Junos devices.
Yep.
I refuse to let you call the SRX firewall. It's a very good router, however. It's a very good router. It's a really good router. Now, then this kind of loops back to the original question. Why don't we just push configs? This is why things like Terraform, Ansible, etc. exist, or Nornir, right? You have so we have three types, or let's do two types of validation of this is what I want to do. This is the interface that I want to configure. This is the current state. We have client-side validation and we have server-side validation. By that, these are Kubernetes terms. I'm sorry, I've been too far down the rabbit hole, but when you do the device level check, you push your whole config over and then you get the feedback back from the device. This is the difference in config. You've done server side because you have actually applied something. You haven't actually pushed the configuration, but not all devices have this capability. There's a reason why a very complicated Ansible module or a very complicated Terraform provider exists that can look at your current state or the state in the JSON file or whatever, and then say, hey, based on what you want to apply here, you already have this information, this is already here. The only thing that changes is this. And that's what you put into your change ticket when you go into your Jira or your ServiceNow. Because if you keep telling your boss, I'm applying this whole 4,000 lines, weren't those 4,000 lines already on the device? Yes. What did you change? I have no idea. Good day, sir. That's not a good way to roll your business day to day. So that's why we have things like Terraform, like Ansible. And that's why kind of, Terraform's been taking the lead lately. There's wins, but client-side validation is what they can do if they're well-written modules. Not all modules support this. Many, like the cheating that can be done by using the actual devices, state diff checker, if we just call it the diff checker, that, you can use that, but being able to do it client-side means you don't have to actually touch the device, you don't have to access production, and dry running, just to, emphasize that again, when you're getting started, especially, dry run capabilities are going to be very important because automation is just going to let you fail at the speed of light if you start screwing around in production. So the ability to be able to actually take production configs and know that you can't actually push to them, and you can actually run dry runs that would say, hey, you want to do this, but this is the change that would happen. I haven't applied the change, but this is what would have happened. And then you can go, yeah, this is good. I feel good about this. And then you can get more confident. So that's why all devices are not equal. Thank you for coming to my TED Talk.
But Steinn, you're right. Terraform is actually a good tool for the firewall management because they have parity across all the cloud providers as well as all the on-premise firewalls. So if you're thinking about how do I manage all these firewalls, Terraform is a pretty good idea for that. Again, it might not manage your base config, your AAA and all that kind of stuff, but managing policies and address objects and all of that's a pretty good way to do it. And like you said, yeah, you get the plan, so you do get kind of a diff to see whether you're happy with your changes before you apply them. And it's multi-vendor.
I think I will. Yes.
Yeah, go ahead, sir.
I think I interrupted someone. I will be really quick in terms of firewall automation. So Adam, you mentioned Terraform is a really good tool for automating firewalls. So speaking from my experience trying to automate Palo Alto firewalls, they have a really good REST API. They have an SDK for Python. They have a Terraform provider. They have Ansible modules. They have everything. I even tried Terraform to create policies. But the problem is, I mean, if you look at most of the examples from blog post or video, they have a really simple use case. Okay, you put the source IP, you put the destination IP, you put the port number, here you go, your rule is there. But in reality, you might have 500 rules already on the firewall. A new request comes in. Now you had to decide, okay, do I need to create a new firewall rule for this new request? Do I need to create a new address object? Or do I just need to go and edit one of the previous rule by adding a source IP or destination IP? So that's where the firewall automation gets really complex. And if you decided to use Ansible for Palo Alto, for example, and if you have 1,000 rules, it will take minimum 30 minutes for the whole thing to run. So it kind of slows down everyone. And if you have 500 object, 500 address group, and 1,000 rules, it will take minimum 30 to 45 minutes. Speaking from my experience, that's why I kind of hate automating the firewalls. For me, it's so much easier to just go to the GUI, just edit the rule, and then commit, and then 2 minutes job. But if I want to automate, it could take like half an hour just to create a simple rule. So it's,
yeah, but if you're doing it across like 10,000 devices, then logging into every single GUI is going to take you quite a while. So in that or even 50 devices.
This the vendor-specific management panel team comes in and goes, well, you should buy our management software, and it's going to be really nice.
Yeah.
Yeah. I don't want to prolong the conversation, but yeah, even if you have 50 firewalls, then it gets even more complicated, right? Because where do you create the rule? Like you had to have some kind of logic to see, okay, this source IP, which firewall do I need to create the rule in? If you have like 3 firewalls in the path, you need to create some kind of logic to see, okay, I want to create this firewall rule on this firewall, this firewall, this firewall. So I mean, I tried it. It's not impossible, but it's extremely difficult to automate the firewall rules in my experience.
It comes back to abstraction. So the way that you have to do that, or the way I've done it before, is through abstraction based on zones. So you have an abstraction layer where you define, this zone to this zone can work, and this zone to this zone has these policies. And then just depending on what firewalls have which zones, they just get those policies configured on them. And then it doesn't really matter about, I guess, source addresses, because it's just a source zone. And the destinations are also just dynamic to an extent, because they're just based on destination zones.
Yeah.
So I've never done this in production, but the best thing a friend of mine showed me the other day was tag-based, fully cloud. They had I believe they had the Cisco or the Checkpoint, doesn't matter which product, but anyway, each resource inside of their Azure tenancy has a particular type of tag. That means it gets access to this or that or whatever. And the devs can actually apply. This is dangerous, of course, but the devs can actually apply to their resources certain pre-created tags. And then all the policy happens automatically in the background. And then my guy goes home and sees his kids. And that's, of course, a single firewall instance, but, not the 100 brownfield, scenario that we're dealing with. But there's a light at the end of the tunnel.
That's a great topic, though. You're now going into the world of making changes without approval, and that's a whole other world, which is around policy-based, validation.
He had the actual, has the actual approval. He can pick which tag, and then that goes through peer review. So it just cuts out the network person and goes purely to the product. So for standard changes.
For standard, yeah, exactly. You have to be very good at defining policies of what is standard and what's non-standard, and what needs human approval, and what can just be, 4 a.m. the developer's up and just presses adds a tag and it just gets configured automatically.
Sounds like we could possibly have a whole webinar or session dedicated to that particular topic as well. It's quite a meaty one, isn't it? Yeah. But thank you for that input, guys. It's fantastic. Mark, did you want to move us along? Just conscious of time now.
Yeah, sure. We're just on the last slide where we can do Q&A and closing remarks. Yep. I want to start, in case we get into questions and run out of time, I just want to say a huge thank you to all of our panelists. Thank you for coming here today and sharing with everybody. This, like I said, is the first one in this series. We're going to be doing more. As Rich said, it sounds like we should have a dedicated hour on firewalls. Not exactly sure what we're scheduling next, but there's some more coming up. There will also be a blog post that follows this. They'll go out on netboxlabs.com, where we'll capture a lot of these ideas for easy reading offline, and we'll be sharing the webinar recording somehow, some way, at some point after this. So thank you all. Are there any questions? Let's have a look. I see a ton of chat that I haven't really been monitoring since the beginning.
Yeah, no real questions as such, Mark, that have come in. I think there's just been some general discussion. People talking about legacy network devices. Modern network devices actually. And the only way you can push out a config change is to do a factory reset and ZTP the config onto it and things like that.
I see one here at least. So Nicholas asks, what are your opinions on ensuring compliance when generating configs and devices? And here, yeah, our entire conversation has been kind of one way, basically, like, we're pushing a magic config and we're going to make it happen through a standard change. But the compliance rule, like if, you have certain rules in your organization that should never happen, this is where we get into that little feedback loop, which is an entire topic unto itself. But one of the things that I do in, in my main data centers is we monitor IP fabric. Since, we have multi-vendor devices, we go talk to the IP fabric, wonderful people at IP fabric that, and we query that API that has, a uniform state view of, our entire VPN, v4, MPLS network, our VXLAN, whatever. And then I can just run some queries on that to make sure that, nobody is originating a prefix that's not assigned to them and that type of stuff. And I don't have to do it per device or per OS. So, that's one of the ways that we do compliance, but it's a very long topic. Anyone want to follow up with the compliance question?
Yeah, so compliance is kind of tricky because sometimes you're kind of you could look at it two lights. One being validating the actual config like making sure that the syntax is there. Sometimes that's required, sometimes by regulation or by law. But other times you're looking at the operational state, and that kind of goes kind of into the IP fabric talk where you're almost validating the state of the network. So you're looking at, show command output, just validating that the network is operating as it should. So you kind of look at, two-prong approach there. Assuming you're talking about the config compliance, that's where abstraction is key, right? So the same abstraction you use to generate config, like we'll use the VLAN example, VLAN ID, VLAN name, you can use that same abstraction level to validate that that is actually in your network. And that could be through collecting configs and validating using that abstraction. But yeah, so that's where it's key of when you're building out your automation, having, that source of truth, whether, we're talking about NetBox here, or if you're just getting started, maybe a simple YAML file, using that file or that source of truth, you can kind of double up for generating configs, but then also ensuring compliance.
That's great. I don't know where it is now, but Craig Pund has raised a hand. How do we give Craig a mic?
I think just we can unmute Craig. Oh, no, he says apologies. That was a mistake.
Okay, got it.
It's okay, Greg. We all have those days. David did ask though, what sorts of truth do people use for their firewall rule automations and NetBox doesn't cover it? Well, doesn't NetBox cover it? You see, if you've assigned prefixes and you use enough tags, anything is possible. And that's kind of what we're playing around with. Right now, we're just doing Git and then revalidating using IP fabric and most of it's not automated. It's mostly just making sure the change management happens correctly. I wish I had more. Anyone else got a source of truth or firewall?
It's a great question. There are a lot of vendor solutions, right? I think there's like 2FIN and AlgoSec, and there's a lot of vendors in that space if you want to find people like products that are just firewall management platforms. I think they're called policy assurance platforms, I believe. So that could be something you look at. But in terms of like an open source NetBox like or a NetBox native way to do it, I think I saw that there's a bug bounty, or not bug bounty, a plugin bounty, what are you guys calling it? For someone to design a firewall plugin for NetBox. So I think that'd be very exciting. But I think the reality of what I've done is like Steinn was saying, just putting it in Git, using YAML files or using XML files, whatever you're doing, and then generating from there.
There is also Ditmar. Oh, sorry, just real quick. Ditmar dropped a link to Project Airleon. We see those guys. They're over in the NetDev chat, and they integrate into NetBox as well. So that's one of the options we see. Go ahead, Suresh.
Yeah, I'm just going to say the same thing. We create most of the firewall rules via Ansible. So what we have in Git is our source of truth. So all the rules we need to create it through the YAML file. So if we need to create a new rule, I go to Git, create a branch and then apply the rule. So the Git repo becomes the source of truth. But again, that doesn't really stop someone from going to the GUI and create the rule if you don't have a strict policies.
All right. We are about 30 seconds away from the top of the hour, so I'm going to call it now. We can stick around for a little bit. I see some hands coming up for additional questions, but if one of the panelists needs to drop, thank you so much. We appreciate it, and hopefully you can join a future one of these. We're going to continue with any questions that have come through. We have a raised hand again, and I again don't know how to do this. Let's see. Did the hand go down?
By next time, though. Oh boy.
Oh yeah.
Can you unmute them, Mark? I think that's the.
Oh, Dara Toma is now saying thank you all. So I think Dara, who had their hand up, has put it back down again. All right. Any other questions before we call it?
I think I'm quite amazed that we didn't mention the word spreadsheets in terms of config generations. So I thought that was an achievement.
We're moving forward.
Just shame and peer pressure, dude, that,
Someone has a CSV in there somewhere. Don't lie.
I got all my SFP models in the spreadsheet still, man. Like, it is what it is. It's fine. It's fine.
Cool. All right. Thank you, everyone. Last question. Andrew asks, will there be a replay of this presentation? Yes, the video will be going somewhere. Keep an eye on netboxlabs.com for that. You can also join the mailing list to make sure that you don't miss out on future goodies. Thank you to everybody who attended. Thank you again to all of our panelists, and we hope to see you sometime in the near future. Bye-bye.
Thanks, everybody.
Thanks.
Thank you, guys. Bye. 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 Bye.
We're good. All right, closing. Ta-da. Bye, everyone.